let us get started. Students, observe the terms of this sequence. What is the ratio between each consecutive term? That is correct. The ratio is 1/2, or 1/2. We can see that the ratio between each consecutive term is a constant. This means that this is an example of a geometric sequence. A geometric sequence, also called a geometric progression, is one in which the ratio between consecutive terms is a non-zero constant. This constant is called the common ratio. For example, sequence Gn is a geometric sequence if and only if Gn plus 1 equals R times Gn when R is a real denominator. The common ratio is R equals Gn plus 1 over Gn for all n. From this definition, we can see that if G1, G2, G3, and so on to Gn is a geometric progression, then G2 over G1 is equal to G3 over G2, which is equal to G4 over G3, and so on. This is equal to Gn plus 1 over Gn, which is R for ratio. In the same way, G2 equals R times G1. G3 equals R times G2. G4 equals R times G3, and so on to Gn plus 1 equals R times Gn. Therefore, G2 equals R times G1, G3 equals R squared times G1, G4 equals R cubed times G1, and so on to Gn plus 1 equals R to the power of n times G1. This set of relationships proves a theorem for the general term Gn. If sequence Gn is a geometric progression with the first term G1 and common ratio R, then the nth term is given by Gn equals R to the power of n minus 1 times G1. Let us apply this formula to an activity, students. Your class decides to save for a trip to Addis Ababa, starting on the first day of the month. The trip will cost about 15,000 birr. The class puts aside 1 birr in the first week, 2 birr in the second week, 4 birr in the third week, and so on. If the amount saved doubles every week, how many weeks will the class need to save before it can afford the trip? Do your best with this question, and I will see you in a few minutes.
Students, let's get ready. Begin. Time's up. let's get back to our lesson.
Welcome back, students. Were you surprised by your answer? G1 is 1 birr, and the ratio is 2. Therefore, Gn is 1 times 2 to the power of n minus 1. Now, we must find our answer through trial and error. Let us start by calculating how much would be saved after 10 weeks. G10 equals 1 times 2 to the power of 9, or 512. 512 is not nearly enough for the trip. So, the class will need to save for longer. What about 20 weeks? G20 equals 1 times 2 to the power of 19, or 524,288. That is far too much. What if the class saved for only 15 weeks? G15 equals 1 times 2 to the power of 14, or 16,384. Perfect. The class will have enough for the trip and even a little left over. Was your answer 15 weeks, students? Great job! We have time for one more activity. Observe these 3 sequences. Try to determine whether they are arithmetic or geometric. If the sequence is arithmetic, find its common difference, D. If the sequence is geometric, find its common ratio, R. You may get started right away.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. I hope these sequences did not give you too much trouble. Shall we look at the answers together? The first sequence looks like it is arithmetic, does it not? It is described as AN equals the sum of 8 and n over 2, where n is a positive integer. D equals 1/2. The second sequence is geometric. It is described by the equation 3 over 2 times 3 to the power of n, where n is a positive integer. R equals 3. The third sequence might have been a bit tricky, students. That is because it is neither arithmetic nor geometric. It is a sequence of numbers that has no defining formula. Remember that not every sequence can be solved, even if it looks simple. That is all for today's lesson, students. We have learned about geometric sequences and how they can be employed to solve real-life problems. We have also learned to tell arithmetic sequences apart from geometric sequences. And we have been reminded that not every sequence can be solved. Until next lesson, thank you, teacher. Thank you, students.